Hey everyone, I'm Ajit Anwani. I'm a research scientist working with Verily and Google Research. Today I'll present RepsNet that combines vision and language modalities for generating automated medical reports and show its application to radiology. Radiology is among the most widely connected domains across medical fields, with over 1 billion radiology examinations performed worldwide with an error rate of 3 to 5%, taking 5 to 10 minutes on average to document each report. Taking a closer look at these radiology errors, we see that most of them are related to perceptual findings, with up to 42% of errors due to underreading of the report. Examiners tend to stop the search after the first finding, or their reasoning is found faulty, or there's a tendency to rely on the previous reports heavily. We believe that writing reports by analyzing medical images is error-prone for inexperienced practitioners and time-consuming for experienced ones. To this end, we develop an automated reporting system that can decrease practitioners' burden in writing and explaining results, that can improve report accuracy and quality by automating billing codes, and be able to interactively reduce the gap in the patient's understanding of the medical content. Our framework, that we call as RepsNet, parses the medical report into a set of questions and handles both categorical, that are yes, no, or multiple choice answers, as well as natural language descriptive answers that are open-ended in a visual question answering setting. Given an image and a report question answer pair, we jointly pre-train the visual and the language features in the first stage for cross-alignment in the embedding space by contrastive learning. For classification, we then fuse the image and the question features with a bilinear attention network and linearly project them to the classification head of all possible categorical answers. For generating descriptive answers, we adapt the GPT-2 language decoder model and condition on image features, as well as prior reports for additional context that are retrieved by nearest neighbor search of the image features in the embedding space. We evaluate RepsNet on two well-known datasets, VQ-RAD, which comprises of X-ray, CT scans, and MRI to categorically answer questions such as what pathology is seeing at the lung basis and so on. And we use Indiana University X-ray dataset to generate open-ended descriptive findings from a pair of frontal and lateral chest X-ray images. Results show that RepsNet gives state-of-the-art classification accuracy on VQ-RAD datasets. We also note that filtering out imbalanced classes with less than 5 or 10 instances further improves the classification performance. RepsNet also outperforms state-of-the-art models for generating descriptive findings in terms of the blue scores on chest X-ray datasets. The ablation studies reveal that pre-training with large vision and language models help in performance improvement. Joint pre-training with contrastive learning, as well as adding prior context of neighboring reports, helps in generating medical findings. Let's see the performance of RepsNet in the web application demonstration here, where the user can upload an image and a report question, and you can choose the model to classify or generate text. Here we sample them from the test set, where we see the comparison with the ground truth along with the heat map visualization and the prediction confidence. We can also generate these descriptive findings where we also show here the comparison with the ground truth in terms of the blue scores, as well as the nearest neighbor context and its contribution to the predicted finding. We extract here a couple of examples for qualitative understanding of the results. The model shows strong alignment with the ground truth in generating medical findings. However, it often adds, removes, or rephrases some of the findings, which needs to be further evaluated in a clinical setting. We are continuing further work in grounding medical text and images and generate report from videos directly, where in addition to a textual answer, we also have a visual answer or temporal segment associated with the report question. We had promising results for video report generation, especially in the context of text-to-video retrieval problems. We're working towards its deployment on real colonoscopy procedure to populate parts of the probation reports. To summarize it all, we have presented RepsNet that adapts large-scale pre-trained language and vision models for writing out parts of automated reports. We pose the problem in a visual question answer setting and derive state-of-the-art results in radiology by contrastive joint pre-training and adding visual and prior context of similar reports for medical language generation. Please visit our website for more details and reach out to us in case of any questions. I thank you all.